Okay, so for anyone who was away yesterday, just so you know, this little symbol right here, if it has a little red dot, that means it's recording, which means that if you are away, you can actually go and watch the video if you need to or if you want to. Okay? You don't have to, but it is there for you if you want to. Where would you find those videos? On Teams. So if we go to Teams really quickly and we say, where would I find that? Not in Chemistry 12 AP. So I'm going to go to Science 9. And over on the left, it says lesson videos. And you can see here is last day's lesson. Okay? So if you wanted to watch last day's lesson, I don't know that we did very much, but you could if you wanted to. But like I said, I don't edit it. So if we spend 20 minutes doing classwork and you're just like seat work, there's a good 20-minute gap in the middle where nothing happens. Okay? I don't have time to edit. All right. So we are on page, what page are we on? 13, 1-3, page 1-3. Oh no. It's doing the disappearing text thing again. Okay, I'm going to close it and open it and hopefully that fixes it. Oh, it's back. Okay. It's been misbehaving all day. So if you see me get grouchy face, it's because this thing is misbehaving. I've been growling at it. So we have page 13. And what I would like to know is if there are any things on this whole list that you thought were kind of weird or you weren't sure about. Anything that made you say, Perhaps not that loudly or dramatically, but that made you say, yes.
Flavor.
Flavor, that's a good one. Absolutely. And that, I'm trying to move it with my finger, but it's not letting me. It's just drawing lines. And that's when I get grouchy and look at it and get frustrated. But that's all right. We're going to make it work. Flavor. So you could argue two different ways on this. You could say, I have flavor, which is like the little molecule. Have you guys heard of molecules? Okay, they're tiny little particles. And every substance that has a taste has a little molecule. Maybe it looks like this. Okay, little molecule. And that molecule, there's your tongue. And it goes into a taste bud. And in goes that molecule, and that makes you taste a certain flavor. If that's how you chose to interpret flavor, would that be matter or would that be not matter? That would be matter because we have a molecule, which is a particle. It is a thing. It's really tiny. It would be really hard to measure its mass, but it does have mass. It does weigh something. And it does take up, what's the other thing? Space. It also takes up space. So it has mass, which is the heaviness. And it also has, what do we call the thing? How much space it takes up? Do you guys know what that's called? That's called volume. Okay, so it has mass and it has volume. So if that's how you choose to interpret flavor, it would be matter. But what if you think, oh, flavor, that's just my brain getting signals from this chemical. So it's really my brain's interpretation. So if you thought that flavor is your brain's interpretation, would that be matter or would that be not matter? That would be not matter. Would this be a good or bad question to ask on a quiz or a test? That would be a bad question unless I asked you to explain your answer, right? I could say, justify your answer. And you could say, oh, well, I thought it was like a molecule. But probably I won't do that to you, Okay, I tend to be I don't like marking a lot of like words, so I like things that are shorter. Anyway, okay, any other ones that you looked at and you were like, yes, Ryan.
What is fragrance?
What is fragrance? Fragrance is a smell. Okay, fragrance is a smell. So, what do we think? Fragrance matter or not matter?
Depends.
Yeah, again, it depends. It's just like flavor. If you think that the fragrance is those little molecules that go into your nose and they attach to the receptors in your nose, then it's matter. If you think it's your brain's interpretation, then that is not matter. Any other ones? What about a rainbow? What do we think about rainbow? How many people, don't tell me what you thought, how many people think they know? Okay, I got like maybe 2/3 of you, maybe. Okay. Anyone want to share? Yes. Not matter. Yeah, it's very much like a reflection. Okay, so neither of these are matter because they have to do with what are we looking at when we see a rainbow? We are seeing light. The light has been split into all of its different colors, but light is a form of energy. Okay, so it is not matter. Yes? Flame. Good one. Good one. Good one. Okay. Let's take a look at flame. So when we think about the flame, we got let's pretend we got a little fire here. We got some logs on the fire. You know, we got okay, I cannot draw. I'm really sorry. That's supposed to be some logs for a fire. And then we have the fire. There's our flame. Okay. So we're not looking at the logs. What we're looking at is this part here. What do you see when you're looking at that? What is that made of? It's made of heat. And it is also made of light. So the flame itself, not the smoke, not the logs, none of that, but the heat and the light themselves, those are both forms of energy. And so those are non-matter. And if you tried to say, take a flame and say, what's the volume of that flame? Right? And you tried to put it in a container. Could you put the flame in a container? No. Right? Could you weigh the flame? No. So if you can't weigh it, and like I said, sometimes the particles are so small it would be really hard to weigh it, but if you got enough of them, you could weigh them. But you have to be able to either not either. You have to both be able to weigh it, and it has to be able to take up some space, some volume, in order to be matter. Any others that were either confusing or interesting? Are we good? Moving on? Okay, so we are moving on today, and we are going to go to mass versus weight. Okay, and we're going to watch a little video, and we will fill this in kind of as we go. So let me grab my book so I know when to stop and when to fill things in. And we are on page 14. Page 14. Okay. Why we have no sound? That not good. Sound is on. Sound is on. This is not on. Oh, I know. Speaker gone. That's what this plug was for. Okay. Yes. Sorry, I thought you had your hand up. No, never mind. I'm imagining things. So that's going to be number 1. And I'm going to erase some of this. So let's just remember that flex is for homework and help and a quiet workspace. There are no phones and no noisiness. And now I'm going to erase that. And we're going to write down number 1. Close enough. Number 1 is weight. Get a pen that works. So you can fill that in. Okay. So it is the vertical force exerted by a mass as a result of gravity. So if I have this pen, the force of gravity is exerted upon this pen by some mass. What is the mass that pulls on this pen? Sorry? Its weight. It has some mass. Yeah, so that's one of the things that's doing the pulling. You need one thing that has mass and another thing that has mass in order to have gravity. What's the other thing that has gravity? Yes, the Earth. The Earth is a great big huge mass. And that's why when I drop the pen, it falls towards the biggest mass present. It falls towards the Earth. Because technically, there's a force of gravity between this thing that has mass and me that has mass. But you'll notice when I drop the pen, it does not go flinging towards me. And that's because my mass is a lot smaller than the Earth. Okay, so that's why pens don't go flinging towards you or the table or anything else. Well, I guess they do go towards the table as long as it's in the direction of the Earth. But yeah. All right. That was number 1. Oh. So that's going to be number 2. Weight is dependent on gravity. So what that means is that if the weight changes, if the gravity changes, the weight will also change. And here's a little example of that. Here we have an astronaut standing on Earth. Those are very heavy spacesuits. Okay? And so number 3, on Earth, an astronaut weighs about, how many pounds? 360. But now what's he doing? He's floating through space and he's going to land on the moon. Okay, let's find out how much he weighs there. Okay, so on the moon, the astronaut weighs how much? 60 pounds. Do you think I'm going to make you memorize these numbers? No. Okay, I'm not going to make you memorize them. What you should see, though, is that if you remember from the past one, There we go. No, where is it? Come on. The moon has 1/6 of the Earth's gravity, 1/6. What do you notice about his weight?
It's down by 300.
It's down by 300, absolutely. What is the multiple here? Yeah. This is 1/6. He has 1/6 of the weight because the gravity is 1/6. Does that make sense? So if you went somewhere that had 1/10 of the gravity, you would weigh 1/10, right? So that guy would weigh 36 pounds in his astronaut suit. So on the International Space Station, I don't know if it's still up anymore. Do we still have an International Space Station? Yeah? I know that the original one is now gone, but I think we still have one. Okay. So on the International Space Station, where there's very little mass, because the space station is not very big, how much does the astronaut weigh?
Nothing.
Nothing. So, is that a good weight loss plan? I would like to lose some weight. Should I just go to the moon? Will that make me healthier?
Maybe.
Maybe, but probably not, because there's no atmosphere up there. I'd have to live in a spacesuit and my bones would get less dense and all those things. But at any rate, so it weighs 0. I put that little line through it so it doesn't look like an O. I'm going to erase the washroom thing here. So remember, when you go to the washroom, you're going to, and I got the little book today. This little book right here, it says name, time in, and time out. And if you're like, I cannot read that clock because I do not love the analog clock, that's okay, because the phone here has the time on it digitally, okay? So if you're looking and you're like, oh, I want to, write the time out and the time in, you can look at the clock. There's a pen here. And I promised that I would get us a hall pass. I tried wearing the one that had the Hawaiian leg on it, but it was very uncomfortable, and I thought no one's going to want to wear that. So I instead brought the Inca Trail, okay? And so when you go to the washroom, you get to wear a hall pass. This is our hall pass. I know you're looking at me like I'm crazy, like I've grown 3 heads. But what it means is there's only one person out of the room at a time, okay? It goes in the box. The only reason for the box is it makes this noise when you put it on the counter. And when you put it in the box, it does not make that noise. Okay, so that's why I've got a box for it. And that's just to make sure I don't have anyone who's like, oh, I need to go to the bathroom. Oh, I need to go to the bathroom again. Oh, I've gone to the bathroom for 20 minutes today. I'll go for 20 minutes tomorrow, because we're supposed to be keeping an eye on bathroom usage. It's one of the school goals. So there we are. Okay. All right. Moving on. Okay, so gravity equals, oh, I don't have room. I need to get rid of cell phones. So remember, where do cell phones live? In the cell hotel. When do you put them there? As soon as you come into the room. Okay, I haven't been checking today, but every once in a while I'm just going to go over and check and make sure your phone is there. Okay? Cell phones is going away. I'm going to get another book for lates so you can sign in. I didn't get one yet because I thought probably you're not going to be late for period 4, but I'll get another one. And I'll have to contact home if there's too many. Let's not do that because nobody wants that. All right, gravity equals mass times acceleration due to gravity. And if you're like, oh my gosh, that's a lot of writing, you can write the shortened form instead. Okay? So you can say gravity, grav, equals. And today we are going to learn the symbol for mass. And I think a couple people in this room have already done that. Do you remember the symbol for mass? At the back, far corner there. Do you guys remember the abbreviation for mass? Maybe not? That's okay, we're going to learn it again today. Does anyone want to take a guess as to what we use to represent mass? We just use the letter M, yeah? Okay, so it's just the letter M. Okay. And anyone want to take a guess about acceleration? A. It's nice when they make sense. Now, it actually does matter whether it's a capital M or a little m. If you write a capital M, that stands for molarity. And if you take chemistry 11, you'll learn about that, but not in grade 9 because that's too much. Okay? So little m, little a. Do you need to memorize that? No. Okay. Okay, so that's the force it's pulling you down with is 9.8 meters per second squared. So that's how much you speed up every second. So if you were being pulled down, if you jumped out of an airplane, hopefully you've got a parachute on, but let's say you didn't have a parachute on, there was no air resistance, in the first second, you would go from 0 to 9.8 meters in a second. And then that would happen every second squared. I'm going to let your physics teacher tell you about that because that's more than my brain can handle at this time of day. Okay? So you'll learn about that next year in physics in Science 10. Okay, so mass just means your thing is made of particles. So that's number 8, mass. Did I miss one?
Yeah, gravity on Earth.
Oh, gravity on Earth. Number 7, the gravity on Earth is 9.8 meters per second squared. What do you notice about the symbol for meters? It's also a lowercase m, okay? This one is a quantity. This says, I am measuring mass. I am measuring how much stuff there is in this pen, for example. I'm measuring its mass. How much particles are in there. This one, because it comes after a number, that's not something I'm measuring anymore. That is a unit. Okay, and the unit tells me what I'm measuring. So if I was measuring distance, I would say distance, which is d. Okay, and if I had 12 meters, I would write 12m for meters. Don't worry about writing that down right now. We're going to go over some more of this a little bit later this class. Okay, but that just gives you an idea. And you're like, what is she talking about? Don't worry about it. We'll get to it later. That's number 7. Do you need to memorize that number? No. Okay. Number 8. Number 8 is mass. Mass is the property of a body that causes it to have weight in a gravitational field. And mass, does it depend on gravity? If I went to the moon, would I have a different amount of matter in my body? No. And mass is the amount of matter in my body. So my mass doesn't change when I go to the moon, but my weight, the pull of gravity, does change. So number 9, the mass of an object and you guys all know, homework is checked at the beginning of the block unless you weren't here last day. Now you know, and you're here. So we just bring it up to the front and check it. So homework can go away now. You get 10 out of 10 just for having completed it. All right? And especially on Tuesdays and Thursdays, there's no real reason not to have it done, because if you don't have it done before class, you can always come to Flex and do your homework on Tuesdays and Thursdays at least. Okay, that was 7 and 8. Number 9 is also mass, because mass does not change if you go to the moon. Okay, so number 10, mass is the amount of matter. So number 10, mass is the amount of matter. I've got a bunch of dead pens I need to get rid of. Matter. What is a force that governs motion throughout the universe? That's number 11, gravity. So what he's saying is right now, the reason these people are floating around in the space station is that the space station is falling towards the Earth. But because it's in a circular motion, it orbits the Earth instead of directly falling into the Earth. And that's because it's moving. And there's some complicated physics behind why it doesn't just fall right into the Earth. But again, I'm going to let your Physics 11, Physics 12 teacher teach you about that. Okay? So if I were falling at the same rate as this pen, would it look like the pen is moving to me? If I couldn't like see the background moving? No. Okay, and that's why they float, because they are falling at the same rate as the space station is falling. Interesting. And we need to hit upon number 12. Gravity is best described as an attraction between two whats? Forces. Not forces. Gravity is the force. Okay. It's the force between two. Are you guys like competing here? Yes. Masses, between two masses. So like I said, the Earth is the biggest mass we have around. So usually we just think of gravity as being towards the Earth. But there is a small amount of gravity that pulls this pen towards me. But not very strong. So that's why it doesn't fling towards me. Okay, that was number 12. Number 13, near Earth's surface. I don't know what goes in that blank. Sorry? Normal? Good. I was going to guess normal, but then I wasn't sure. Normal gravity. So number 13, normal. Maybe I need to get rid of that one because it doesn't immediately pop out. Normal gravity is, we just call it 1G, okay? Because it's really easy, a lot easier to remember 1G rather than remembering, oh, and I need to erase quizzes now to have somewhere else to write. What do you remember about quizzes? You can retake them as many times as you want to get the mark that you want. And do we have any quizzes coming up? Yes. Where would you look to find the quizzes? You would look on Teams. It might be in the homework section, but you can always find them in the upcoming quizzes and tests. So next Monday, there's going to be a quiz on quantities and units, which we're going to cover later today. So the quantity would be like mass, and the unit would be kilograms. Okay. All right. Where do we get to? Here we go. So number 14. One G is equal to 9.8 meters per second squared. And that just gives us a nice, easy number to look at rather than 9.8. And one thing you'll notice is that very often when you get into physics and they're like, we just want to be close enough. Instead of 9.8, can you guess what number they might use? 10. They might use 10. Okay, so you can often approximate things by just using 10. $28,000 kilometers per hour. That is number 15. Tests. Let's get rid of tests. Can you redo a test?
Yeah. No.
No. But what happens if you get below proficient on a test? You can come in and do corrections with me. We'll have a talk about it and you'll do some learning and we'll bring your grade up. Okay, so if you were emerging, you might move to developing. If you were developing, you might move towards proficient. Okay, so hopefully by the end of that, you'll have a better understanding. All right, and number 15 is 28,000 kilometers per hour. Do they look like they're moving that quickly? These guys up here? Because that's where they are right now. Do they look like they're moving that fast? No, why not?
Isn't like the answer, I don't know if you know the answer, but my question.
Yeah.
Do they even have to hold a mic?
Do they even have to hold the mic? Maybe not, but it does keep it near them, whereas it might bobble away from them. Do you know what I mean? Like it could probably stay there, but you know, if you breathe on it, the molecules from your breath will push on it and will move it away. So it's just probably more convenient to hold onto the mic. At any rate, it does not look like they're moving. Yes?
Wait, so about like your question.
Yeah.
The atoms in the spaceship are going up the same velocity that and then the atoms outside are like stick, so like the traveling with them.
Yeah, so they're moving in relation to the outside, but the astronauts are not moving relative to the spaceship because the spaceship is moving at the same speed they are. And we're just looking at the spaceship and we're like, oh, doesn't look like they're moving at all. Does that make sense? Okay, you're all just staring at me. We've been doing this for too long. Okay, we're going to take a break real quick. And we're actually going to pause there for today. There's actually a couple little cute things that happen here. We'll watch that tomorrow. Okay, first thing. Because I feel like you've been sitting for too long, and wouldn't it be nice to go and take a short walk around the parking lot instead? Would we like that? Okay, so we're gonna go outside, we're gonna walk around the parking lot, we're gonna come back, and we're gonna learn some units. Okay, so follow me. When we get out there, I know we only have 15 minutes left. Let's go.
I can't drop the rents. I can't. They're all over. They keep her pushing a chair for me. I was drawing my
I think everyone actually listens to the teacher.
And you're not winded, and I am. I've been waiting for work.
All right. we're going to finish up really quickly. We're going to go to page 20, 20. Page 20, 20. Where are we at? That thing. There we go. So these are quantities that you can measure. This is what your quiz is going to be on next week. So if I say volume, you should know that's the amount of space an object takes up. Can you guess the symbol for volume? It is a V, and it is a capital V. Distance. How long an object is, how far an object travels. What's the symbol for distance? It's a D. It's a little d. Temperature. What do you think temperature is? Yes. It's a big T. Mass. M, big or little? Little, lowercase. Time. Yeah, it is little t. Yeah. Because temperature is big T, time is little t. And one way you can remember that, if you have trouble remembering, temperature is a big, long word, right? Time is a little word. Yeah? Ugh. Sorry. Force. Want to take a guess on force? It is an F, but it is actually a capital F. Big F. Okay? So the question is, let's see, we often use symbols for quantities. So your choices for the symbols are T, T, M, D, V, and F. We already did that. We filled those in. Does it matter whether you use a capital or a lowercase? Does it matter? Yes. And by the way, if you ever miss anything that we're doing, all of this is also in the answer key, okay? Or if you ever miss anything and you want to drop by during Flex and get it from me, you can do that too. So seconds, this is the unit. What quantity does seconds measure? Does seconds measure mass? Does seconds measure, it measures time. So we're going to put time here. And we're going to fill in a T. What does meters measure? Distance, yep. And the symbol for that is? Little d, yep. Ooh, here's a weird one. Newtons.
Yes.
It's not actually mass, but you're on the right track, yes. It is a force, okay? So it will measure force. And gravity is a force, right? And gravity controls what your weight is. So it also, this is capital F, but it is also for weight, which is a little W. But this one, I'm going to put it in brackets because you're not really responsible for that. Actually, it should be a WT. WT? Yeah. Liters. See if you can tell your partner what quantity you think that measures. Liters. Yep, liters measures. I heard a bunch of people say it. It is volume, which is a capital V. Grams measures
Closer, come on. Yeah, it's
mass.
It's massive.
Because if you put this on a scale, what does the scale give you? Grams. Okay. Degrees Celsius. Temperature. Is that a big T or a little t? Big, because remember, it's a big, long word. And the mass was a little m. But scientists are inherently lazy people, and we like things to be fast and easy, so we are going to also abbreviate some units. Okay, so we're going to abbreviate. Seconds gets abbreviated as S, little s. Grams gets abbreviated as G, little g. How about liters? It is a big L, which is interesting because then if you have milliliters, it's actually little m, big L. So often people will put little m, little l, but it's actually a big L if you want to get really specific. It really irritates me that our driveway says 10, what does it say? Our driveway says 10 m, which that means something molar, 10 Kelvin molar. What they should say is that it should say 10 kilometers per second, but it doesn't say that. Not per second, per hour, because it's telling you the speed that you should drive along the driveway. But it says this, which is not very good for a place of learning, to have the incorrect unit on its driveway, but that's okay. I've gotten past it. I have learned to live with it. All right, next, newtons. Big N or little n? Big N. Meters. Little m. And then degrees. Degrees is that little 0, yeah? And then we have Celsius, which is a big C. So it is degrees Celsius. It is not Celsius degrees. Okay? And does it matter whether you use a capital or a lowercase for a unit abbreviation? Yes. Okay, and because we have only 5 minutes left, and maybe the bell will ring early like it did yesterday, it rang at 3 o'clock, which is why I realized that my alarm didn't go off before the bell, because it went after 3. You guys can do page 21. Number 6. I'm not going to have you do number 7 because it might get confusing for you. If you want to try number 7, you can try number 7, but sometimes people get confused by it. We're going to do page 22, number 8 and 9. Now, in order to get you started on this, I'm just going to quickly show you how to do the first line of number 6, okay? If you see the quantity symbol V, what does that stand for? Volume, so you would write volume. What are the units of volume? Liters, so you're going to write the whole word here, liters. And what is the abbreviation for liters? Capital L. So you're going to do all of them like that. You'll have the quantity symbol, and then the units, and then the unit symbol. So that takes care of number 6. And number 8, you can do them in whatever order you want. Number 8 is just a blank quiz. This is what your quiz will look like. It'll just be a blank box. Or it'll look like this. It depends on what you choose. You can choose to do the enriched one, which is completely blank, or you can choose to do the one that has one thing in each row. So next week's quiz, you get to choose either the regular version, which has things in it, or the enriched version, which is like number 8, which is just blank and you have to fill them all in. Your choice. Either is perfectly good. And then finally, I just want to cram this in right before the end. Write 6 sentences using the following as an example. The quantity, so I am going to write the quantity. So this is number 9 on page 22. And then I'm going to write what the quantity is. Somebody pick a quantity for me. Any one of the ones we've learned. Sorry? Volume. Perfect. So the quantity volume, and I'm going to put in brackets, big V or little v? Big V. And then it says, is measured in the units. So I'm going to write, is measured in the unit. And if you can't fit it all on one line, there's space underneath, you can continue. And what unit do we use to measure volume?
Sorry, not grams, liters.
Not grams, we write liters. So that's going to be, instead of joules here, we're going to write liters. And then we'll put in brackets its abbreviation, L. So you're going to be doing 6, 8, and 9 on pages 21 and 22. I'll write that up here.
Yeah.
Optional is number 7. Okay, number 7 is optional. And that will be on our Teams in the homework page. And if you would like to go and get your phone now, this would be a good opportunity to do so.
There, on that one,
Feel free to go and take a picture of the homework if you want to. It will also be on Teams. Thank you guys for being a wonderful class today. You participated, you were engaged, it made me happy. Happy teacher, happy life.
Wait, what if you go to 7? Still get into
If you don't do what?
go to 7.
Oh, you still get a 10. Yeah, the 7's just optional. Yeah, you'll get an 11 if you do 7.
8, 7, 8, 9.
6, 8, 9. 6, 8, 9. Yeah. You're welcome. Homework.
You know I was gonna forget it.
But you didn't remember. Good job.
I just came back.
Oh, you just came back. Oh, no. Okay. But you got it. Good. Good, good. You're welcome. Have a great afternoon. See you tomorrow.